bright field microscopy. Both of the exercises we're covering today. Then we are going to work. There is a waiting period time within the labs that we are going to do today. So we're going to work up to that waiting point, which is very early in the process of staining. And then after that, we're going to go ahead and break for 15 minutes so you can do your skills test, which the 15 minutes will include the written part as well as the practical part of doing your skills test. And then after that, we'll resume the lab, and I'll do a live demo on how to use a microscope once you have all your criteria stained. Right. All right, so let's get going. So bright field microscope or bright field microscopy, that's what we left last lab. And so what happens is what we learn in streaking for isolation and the aseptic technique of going from a slant to slant, a plate to a plate, it will be very useful. And actually, when we want to identify microorganisms, later on we'll learn that we can do some of the steps of ID, be a metabolic test and all that, where we will use aseptic technique. However, something that is also really useful is being able to see microorganisms. One thing microorganisms have in common, they're micro, and we can see it with our naked eye. Because of that, we use an aid via microscope. And the one that we use in this class is probably the most widely used, which is the bright field microscope. Now, bright field microscope, it's what you see right here. It has several parts. However, we are going to focus in the parts that we have highlighted right here for you to know. So these parts are the ones that you need to know, and you need to understand what they do. So we're going to start all the way on top where we have the ocular piece. The ocular piece is a lens that will bring the image from the tube to your eye. This ocular piece has in magnification. So it does have a magnification. The magnification of that ocular piece is 10x. Alright, so it means that it makes an object 10 times larger than what it is, or it appears. Now, going from that, we have the body tube, we have what's called a revolving piece. In the revolving piece, we can find the objective lenses. Now this lens, although it does have magnification, it doesn't do the work of magnifying. The objectives, on the other hand, that's where the magnifying occurs, or that's the lenses that will do that power. We have 4 main lenses within our microscopes: the 5x, the 10x, the 40x, and the 100x. This first 3, we consider them dry lenses. They're dry because they don't need the help of a liquid medium in order to observe our image. Whereas the 100x, we call that an oil immersion lens. And that's because we need oil immersion in order to pop that lens and observe our image. So we're going to go ahead and put our magnifications here because we're going to use them later. And our 100x. Now, these can be called by names. So it's called the scanning, the dry low power, the dry high power, and the oil immersion lens. Or it can be called by their magnifications, which is another common. It's another common use. Now we have the stage. That's where the sample's placed. But then over here we have the diaphragm. The diaphragm, what it'll do is it'll help to direct light to it will help with the diaphragm in the condenser to direct light to our sample. Remember, what we're basically doing is shooting light. Light is getting trapped on the microorganism here, and it's being reflected through the lenses. From there, we have the coarse adjustment knob and the fine adjustment knobs. These two are the knobs that will help us to focus an image. Now, just as with regular cameras, we are going to see an image focus depending on the distance between the image and the lens. So what these knobs do is they move the stage up or down to adjust that distance from your slide. The concept, a very important concept, is what we call the working distance. The working distance is that distance that you have between your slide and your objective lens. So that's something that I will repeat to you later on, or when we're talking about microscopy, you'll hear me talking about the working distance. And finally, very important part is the light source, which is basically the vehicle travel with the image. All right. Now, we have these microscopes. They have two main purposes: increasing magnification, so magnifying, and resolution, and giving us resolution. So the magnification is increasing the size of the image. The resolution is improving the clarity of the image. So when we define resolution, what we mean by that is if we have two dots separate from each other, the resolution is the minimum distance on which we can recognize those two things as different dots. For our microscope, we have a resolution of 0.2 micrometers. If we have two separate dots that are closer than that, we will see them as one. Now, these microscopes that we use are both what we call parafocal and paracentric. All right, so if we have our microscope, so we're going to have our microscope slide. And then we'll have right here cover slide at some point. And we're going to be able to see like a circle through the lenses. This circle is what we call the field of view. Now, what happens when we magnify, so let's say this is 5x, and then we change lens and our field of view will change as we magnify. However, our center, where we're locating, will not change. So we're looking at an image larger, or we're looking less of the image in the same center. So this is what we mean by paracentric. Now, parafocal, it means that, but with the focus. Now, because the lenses are different sizes, the working distance will change. However, the stage distance will stay fixed. And that's what we mean by parafocal. That the lenses remain focused when we rotate the revolver without the necessity of moving them too much. It will get slightly out of focus, but we use the fine adjustment knob to do that. I will demonstrate later on in the class. All right, let's continue going with some of the things that we how to take care of a microscope. Now, first thing that we need to learn how to do is how to transport a microscope. So the proper way to do it is with my strong hand, and in this case my right hand, I'm going to grab it. With my other hand, I'm going to put my hand in the bottom. I'm going to tuck it tight to my chest, and then I can safely walk with the microscope. While placing them in my desk, I will place it in my desk, rotate it, and placing it at a distance about 10 inches from the edge, which is a perfect distance for me to put my eyes in the microscope, as well as to keep the microscope safe in our bench work. Now, these lenses, when you the microscopes, when you receive them, the revolver will be set in the 5x. We need to make sure that we leave it like that at the end. Now, what you'll see in the slide when you change lenses is that the working distance will decrease and decrease and decrease. The oil immersion basically will be touching the slide. That's what we put a little bit of oil to lubricate that lens. So what we need to be careful of is that we're not scratching the lenses, because these are very expensive. That's probably one of the most expensive parts of the microscope when we're working with them. And once we go beyond the 10x or low power dry lens, we do not want to use the coarse adjustment node. I will explain a little later when we do the live demo. Oil immersions objectives, they need to be cleaned and wiped with ethanol. If you do not do this, you will have residue of oil in the lenses. It gets crusted, it blocks your view, and sometimes you're focusing at something and you think you're looking at something, but it's just dry oil. And it's actually very annoying. Now, and everything, when you finish, we return back to the 5x. Although we'll do this a little bit later. Now, the magnification that we're working. Now, like I told you, the ocular lens already has a 10x magnification. And my objective lenses have also a magnification. So the total magnification of our microscope is just basically a multiplication between the magnification of my ocular lens times the magnification of my objective lens. So whenever I'm looking an image from using the scanning, I'm seeing an image 50x. So 50 times 100, 400, and 1,000 times. So that's the maximum magnification power of your microscope and your maximum resolution power.